So this is a how-to video on the empirical formula, and it's a short tutorial. So in order to understand the empirical formula a little bit more, you need to know the definition, and that would be it's the simplest form and shows the lowest whole number ratio of elements in a compound. And lowest whole number is highlighted because in the case of empirical formula, fractions and decimals don't work. You can only use whole numbers such as 2, 7, 8, 10, or 22. But these aren't the only numbers you can use. They're just examples of whole numbers. They could be double digit, they could be single digit, they could be odd or even. But that doesn't matter. It just has to be a whole number. So there are 3 questions. And the first one is, a compound consists of 17.6% hydrogen and 82.4% nitrogen. And I'll be doing 3 questions with you today. They're located on page 85 of the workbook, and there's one in the notes, and there's one on the class site. There's a couple on the class site. So first, if you look up here, you need to, find the molar mass of each element. So we have 17.6% hydrogen and 82.4% nitrogen. So I'll write that here. 6% hydrogen and 82.4% nitrogen. And you can see that if you add these up, it'll equal 100% because that's the compound. So you know that hydrogen, the molar mass of hydrogen, is equal to 1.01, and then the molar mass of nitrogen is equal to 14.0067. So that's step 1. I'll erase this. Step 2 is to solve for the number of moles. And for number of moles, you know that you can do mass divided by the molar mass. So you're going to do that for each. So number of moles for hydrogen, the mass is 17.6 divided by 1.01. And that equals 17.4. And then you're going to do it for nitrogen by 82.4 divided by 14.0067. And that gives you 5.9. Okay, so step 3, which is is in 2 parts. So A is find the lowest mole ratio. So if you look, you have to set each up as its own element. So N equals N, H equals. So that's hydrogen and that's nitrogen. And then you're going to take each of the moles that you found here and here, so 17.4 and 5.9, and divide it by each other and find the lowest mole ratio. So 5.9, and since 5.9 is lower or smaller than 17.4, that's what you're dividing by, and that's for part B. So 5.9 divided by 5.9, equals 1. 17.4 divided by 5.9 is equal to 3. And then all you have to do is write out the rest of the equation. So therefore, the empirical formula is NH3, because we have the 1 that's going to go over here, and you know normally we don't write 1s, and then the 3 is just placed here, and you can tell that 1 is from nitrogen and the 3 is from hydrogen. So I'll do another. Our second question is to find the empirical formula of a compound that is 46.3% lithium and 53.7% oxygen. And that's the same thing we're going to find here. Lithium, the molar mass of that is 6.941. And then for oxygen, 15.994. Step 2 is solve for the moles. So using these values, we're going to solve mass divided by molar mass. So number of moles for lithium is equal to 46.3 divided by this 6.941. And then we get 6.7. Then for oxygen is going to be 53.7 divided by 15.994. And that equals 3.36. Now, finding for part A again, we're going to find our lowest mole ratio, and in this case, it is oxygen here. So we're just going to do Li is equal to and O is equal to. And we're going to take this number and divide it by itself since it's the lower one. 0.36 divided by 0.36 is equal to 1. And then for lithium, 6.7 divided by 3.36. And this is really 6.67, but it was rounded, is equal to 2. So when we write out our formula, it will be Li2O. And again, our 2 came from here, and our 1 is here, but it isn't shown. And then I will do one last question. So we have 15.9% boron and we have 84.1% fluorine. So same thing, molar mass of each, and the molar mass for boron is 10.81. Yeah, 1. And then the molar mass for fluorine is 18.99840. Then we're going to solve for number of moles. Divided by 10.811, that is equal to 1.5 moles. And then for fluorine, 84.1 divided by 18.99840 is equal to 4.4. So we're finding the smallest one, and that would be boron, 1.5. And then we're going to divide each by 1.5. And then for fluorine, 4.4 divided by 1.5. And I'm just going to round this off to, it's 2.9, but I'm just going to round it off to 3. So then, once again, when we write it out here, it will be F3. Because our 3 is here, and our 1 is here, and again, the 1 doesn't show. So I hope this tutorial helped you. You can follow up by looking for finding molecular from empirical, And yeah.